Welcome back everyone to the modding tutorial. Today we're going to continue work on the metal press, and I know it will be finished this episode. Once again, it's going to take a while. And I do apologize about how slow this is, but I started a new job recently, so I don't have nearly as much time anymore. But maybe I'll have a bit more motivation to work on it when I do have time. So we wrote the code for the block last time. The tile entity, we've created the class, but we haven't really done anything with it. So let's go ahead and do the recipe type. So I'm going to create a new package, and the way I've been doing this is I have a crafting package and then a recipe package inside of that. I think that's how it still is in MCP. Oh, okay, this is actually in the item package now. Okay. So yeah, these are all net.minecraft.item.crafting, and I forgot to set my scaling option. Let me go fix that. Okay, that should be a bit better, right? I think I'm gonna go ahead and just go with the package names I'm familiar with, so we'll do crafting.recipe. Go ahead and stick a package info file in here. And then the recipe package. And you could also divide this into further packages, of course, but since we're doing something pretty simple, I'll just make it right here. So I'm going to call this pressing recipe. Let's see, what was that hierarchy I was looking at earlier? Okay, I was actually looking at iCrafting recipe, but iRecipe is the basic interface for all crafting related stuff. Let's look at the hierarchy for this. I was thinking there was something missing. So yeah, we've got abstract cooking recipe, and then that has blasting recipe, campfire cooking, smoking, and so on. And I usually follow the convention of having the ing verb because it's something that's doing some action. A recipe, crafting a recipe is a process. That's how I see it. But call it whatever you want. So what we could do here is we could implement iRecipe, and that's a generic type, and it requires some type of iInventory. This can just be an iInventory. It can be something that extends that interface, which would typically be your tile entity. But in this case, what I'm actually going to do is we're going to extend single item recipe. And what exactly do we need to override? I need to check something here. We need matches for sure. And I guess that's it. So the single item recipe, this is used for the stone cutter, and I believe that's the only thing in vanilla that uses it at this time. Okay, so we also need a constructor matching super. That's a mess. Okay, so let's go ahead and clean this up, give these parameters some names, and then we're going to inline some of these values. That's probably, yeah, that's the recipe ID. The string is the recipe group, which we're not even going to be using because this is not compatible with the recipe book. That's the ingredient for the recipe. And the item stack is the result. And I'm going to go ahead and Alt-Enter, put parameters on separate lines just so it's a little easier to read. Okay, so let's go ahead and just make it the group an empty string. So we can knock out that parameter. The ID, ingredient, and result we all need. The recipe type and serializer we could get rid of in this case, but we'll have to come back to those. I'll go ahead and just get rid of the parameters here, and we'll replace these two in a little bit. Okay, so for the matches method, we've got the inventory, which is going to be our tile entity in this case. We're only using the iInventory interface because that's all we need. And that is the world, of course. Okay, so for the matches, this is actually really easy, and why is that not even overridden in the single item recipe? Oh, because there's a stone cutting recipe subtype here. Okay. Well, this is pretty much a no-brainer. So we've got this ingredient field, and this is part of single item recipe that's protected, so we can access it. And an ingredient is basically the things that are inputs for your recipes. And it has a test method. It actually extends the predicate interface right here. So that's where the test method comes from. And we're testing an item stack. And that item stack is going to be in the first slot of our inventory. So I guess that is get item. I don't know what else that could be. Get item and slot 0, the first slot in the inventory. And that's all there is to it. So pretty much any recipe type that you're going to have is going to require a matches method. And I recommend that you try to make this method as fast as possible. If you've got a lot of complex checks that you need to do in a recipe, you want to, at any point that you know you failed, you want to get out of that method as fast as you can just to speed things up, because Minecraft could potentially be looking through thousands of different recipes every time a crafting inventory is being updated. So fail fast in your matches method. But in this case, it's pretty simple because all we've got is that one ingredient and one item to test. So now we're going to need a recipe serializer. So the serializer basically is what it has 3 functions. 1, it deserializes the JSON files for the recipes. 2, it serializes that data into a packet buffer and sends that to the client. And 3, the client receives that data and turns it into a recipe object on their side. So we're basically going to have to do all 3 of those things. And in this case, it's going to be very simple. So I like to do the serializers as an inner class. It's just a nice and neat way to do it. Everything's right here anyway. So for the recipe serializers, they're a bit weird. We want to extend the forge registry entry class. And the type of that is going to be an iRecipe serializer of something. We don't really care specifically. And we're going to implement iRecipe serializer of pressing recipe. Okay, so now we've got some methods to implement. So I didn't know what the official Mojang mapping names were, and yes, we're on the official mappings now, if you missed some previous part. And these methods used to be called read, and write. So now it looks like they're from JSON, from network, and to network. So to network must be the write method, and from network is the read from packet buffer method. So for the from JSON, one thing we're going to need is our ingredient. And the ingredient class has a method, which I'm going to need to learn the name of. From JSON, probably. Yeah, it's got to be from JSON. And yeah, got to rename these here. So this is the recipe ID. And I'm going to go ahead and rename this up here to recipe ID just so it's obvious. And for JSON objects, I usually just call them JSON. So let's actually look at a stonecutter recipe as an example here. Not that. I don't actually know what these are called. Oh, okay, well, I found one. Clicked on it by accident. So with the stone cutting recipes, we got a type here. Every recipe JSON is going to have a type like this. Then we got our ingredient, which is a JSON object. And then we've got our result, which is just the item ID in this case, and a count, which is how many of the result we were producing. So we're going to be doing basically the same thing here. So I'll go ahead and just pop that down here as a reference. Not that I need it, but just for anyone following along. So what we could do with this JSON object is we could call this get method to get a JSON element. A JSON element, we have no idea of knowing what exactly it is until we check it. But you can see there's some other methods here like get as JSON object member name will give you, it's the same thing as get, but it casts it to a JSON object, and it'll throw an exception if it's not a JSON object. But in this case, this method just wants an element, so we can just give it that. So this ingredient here string, that's going to match the ingredient in the recipe JSON. Now we need to figure out what our result is. So we're going to get a resource location, call that item ID. We're going to use its constructor. And we're going to use this Json Utils class that comes from Minecraft. And we're going to learn what the method I'm looking for is called. Probably this one, get a string. Okay, so there's two versions of this. Both start with the JSON object that we're trying to get something from. Then we give it the member name, which is result. And you can also give this, the third parameter is a default value, so if that is not in the JSON, it'll give you the default. If you use this one, it'll throw an exception if it's not present. And since our recipe kind of needs a result, we're just going to let it do that. So we'll let it throw an exception. Next, we're going to get that count field. So we can once again use the Json Utils utility class. And we can get as int. And this one works pretty much the same way. Give it a JSON object. Give it the member name, which is count. So again, this result matches this result here. This count matches this count here. Okay, so we've read all the fields that we care about from the JSON at this point. So let's go ahead and create an item stack for our resulting item. And what we're going to use is this Forge Registries class. And this has all the different registries that we can register things to. And there's an items registry. And we can call getValue and pass in our item ID, which we read earlier. And our item stack also has a count. And I don't think we're even going to be using the count for these recipes, to be honest. So I'm going to go ahead and give that a default value of 1 as well. Okay, and finally we've got everything we need to create a new instance of our pressing recipe. We've got the recipe ID, which is passed into this method. We've got our ingredient that we read earlier, and we've got our result. Okay, so now let's go ahead and take care of these other two methods. So this is the recipe ID again, and the packet buffer I'll just call buffer. Go ahead and rename these two as well. Note that this one has an actual recipe object, not a recipe ID, but we'll get to that in a minute. So now with the packet buffers, what we want to do is we need to write our data that we need in some order, and then we need to read it in that exact same order. So in this case, it might be a bit better to start with the toNetwork method. So what do we want? We want to send the ingredient for sure, and we need to know what our result is, and that's pretty much it in this case. So we've got a recipe object here, and it's got this ingredient object, remember, and it has this convenient method, which I'm going to need to learn the name of. Yes, it completely skipped over it. toNetwork. And we can pass it to packet buffer, and it will write itself to the packet buffer for us. And yeah, there's you can go through the code yourself if you want to. I don't think I've ever actually looked at how the ingredients write themselves to the packet buffer. And finally, we have our result. Yes, in this case, the packet buffer actually has a write item stack method, which I'm guessing is the write item one is the one we want, and we can just pass it the recipe's result. So if you need other types of data with the packet buffer, it has lots of methods to work with. For example, you can write primitive data like ints and bytes. This var int is the one you typically want to use if you're writing integers, because it will try to compress it down into few bytes as possible, just trying to keep the packets as small as they can be. So I think with the write var int, it can be as little as 2 bytes or as much as 4. So if you're sure it can fit into a byte, it might be better to just write it as a byte. But for this recipe, those are the only 2 calls we need. So back to from network, we need to read the stuff that we wrote in toNetwork. So we wrote our ingredient first. So we're going to read that first as well. So ingredient.fromNetwork buffer. And we wrote our item stack second. So let's read that. It's going to be buffer.read item. And that's all we need to create the new recipe. So it gives us the recipe ID, we read the ingredient, and the result. So one thing that I think might be worth mentioning here is, in this case we just have one ingredient, but what if you have several? So a common way to handle that in this case is, if you don't know how many you're going to have exactly, what you do is you write something like a byte, and that will be your number of ingredients, or whatever you're trying to read, whatever type of collection you're trying to construct. And then you'll say, just do like a basic for loop, number of ingredients, and then you'll just write whatever you need here. And then you do something very similar in from network. You'll read a byte, and that'll tell you how many iterations of your loop you need to do, and then you read everything in the loop. Okay, so we still got this error up here where we need a recipe type and serializer. So let's go ahead and take care of those. So I'm going to go down to our setup package, and okay, I've already created a mod recipe serializers class. Yeah, I guess that'll work. And I normally put the recipe types in the same class. How do I want to do that here? Okay, so I'm going to go ahead and rename this to mod recipes just to be kind of consistent with how I normally do it. And we're going to create 2 inner classes here. We're going to have types, which we'll come back to in just a second. And we're going to have serializers. So the recipe types are pretty simple. So we could just have a constant here that's going to be iRecipe type of pressing recipe. Call that pressing. We're going to call iRecipe type.register. And this wants a string, which is, I believe it gets turned, yeah, it does get turned into a resource location. So we need to be sure to include our mod ID. So let's say tutorial mod.mod ID plus, and we'll call that pressing. So you don't always need a new iRecipe type for every recipe serializer, but in this case we do need a new type. So for the serializers, I'm going to go ahead and create a method to help register them. So it's going to be a generic method, t extends iRecipe of, I can't remember if we use a wildcard there or t. I think it's just a wildcard. And this is going to return a registry object of t, registry object of iRecipe serializer of t. Okay, and we're just going to return registration dot recipe serializers dot register, pass it the name and the serializer supplier. And in that case, it's so simple it almost seems like having the helper method there is a bit more of a pain than not, but it will make each line a little bit shorter. Although we've only got one line in this case, so maybe not. So registry object of iRecipe serializer of something. We don't actually care what it is in this case. And we can call this pressing as well because it's in a different class. Register pressing, and we're going to give it a new pressing recipe series dot serializer. And what's your problem? Okay, so yeah, let's go ahead and put pressing recipe in here. And we can convert that to a method reference. And there you go. Maybe put that on another line so it's more readable. Yeah, you know what? I'm just going to go ahead and inline that method. I think that looks clean enough. So does it still have to be specifically? No, okay. So like that, we can use the wildcard there because, like I said, we don't really care what that is in this case. We don't need to know. Okay, so back to the pressing recipe class. We've got these two fields now. Mod recipes.types.pressing and mod recipes.serializers.pressing.get. So remember, that's a registry object, so we need to call get on it. Okay, so that's all I'm going to do on this for today. Like I said last time, this is a lot of work. There's a lot of pieces. We've got the block, the recipes, and next time I guess we'll get started on the tile entity. Then we'll need to do the container and the screen later on. And then we'll have to make sure that the block has a loot table, a model. Gonna need to add a couple more items for this thing to actually produce the metal plates. So yeah, this is probably going to be at least 2 more parts. So thank you for watching, and I'll see you in the next one.